Okay, all right, everybody. We're gonna get started with today's demo. Just to, I guess, run through a quick revision of what we did last week, just containerizing our app. Oh.
Code dot.
Okay, so just to run through what we did last week in containerizing our app, we had this is our original demo from, I think, demo 4. And what we did was create our Docker file to basically essentially tells the computer how to run our app. We, from Python 3.9, the version, we made the directory, we set it to be the working directory, we copied all the information in, and then we ran pip install to install all the necessary libraries and tools and requirements. And then we said that the file to run then, in this case, is python3 app.py. And all that information is in our Docker file. And then moving on to our docker-compose file, this just tells the user what images to run from which containers. And so we just set that to be version 3, our services, and then under that is demo, the name of our image, which in this case is SSHing, that's Shingo's Docker Hub username, and then the name, demo5.-env, and then the ports set to 8,000, and then the environment file, which, as we said last week, contains all of like the super secret top information, like super secret information that you wouldn't want to like people to know. So moving on, we're going to essentially now create a dockerignore file. And a dockerignore file, basically all of the file names put into this file tells you that you do not want this information on Docker Hub. So to do that, we just create a new file in this directory, and that's going to be .dockerignore. And then the files that we don't want to include in this case is going to be our virtual environment. So venv, our pycache file, so __ pycache, and our our venv, our pycache file, and our todo.db, which is, in this case, it's money.db. That's the database itself. So money.db. So just to reiterate, these are all of the files that basically Docker is going to ignore. It's not sent anywhere. So then pulling
pycache, like one extra underline in the front.
Oh, it's 1, 2,
3.
3. Oh, my bad. Okay, so pycache is one.
It has like one too many, and then it's also extra C.
Oh, my bad. Thanks. Okay, spelled pycache wrong. So 2 underscores in the front, pycache, 2 underscores in the back. Okay, so now we basically have our Docker file, our docker-compose file, and we have our dockerignore file. So now we can start to containerize. So that's essentially just docker build. So docker build -t, and then your Docker Hub username, which is in this case snajima/demo. What's the name? Sorry, I spelled it wrong. Okay, snajima/ and then the name of our image, which is demo5-env. And then we're going to name this .v1.0.0, and then another dot, that's the argument for the function.
:v
and dash
colon.
Sorry. Okay, yeah, it's going to be your Docker Hub username, snajima, the name of your image, demo5-env, :v1.0.0, and then another dot because that's just the argument to the function. So now our Docker image is building. Okay, perfect. Now we're going to push this onto Docker Hub. So that's going to be docker push. And then just like basically the name. So snajima again. Najima. I cannot spell his name. Snajima. Sorry guys, this is not my username. Snajima. Just essentially just what we just built. We're gonna then push that to Docker Hub. Okay.
I sent you twice.
Oh, my bad. Okay. Okay, so as this is pushing to Docker Hub, we basically like containerize, now it's pushing to Docker Hub. Let's move on to Google Cloud. The link to this website can be found on the demo 6 page on the textbook. So I'll give you guys a minute to find that.
Also, if you haven't redeemed your credits, that's in the ad announcement.
Yes, you have to redeem the credit. You have to like go to the ad announcement, click the link, and then like link your account to that credit, if that makes sense. Okay, is everybody ready? Yes, no, yes. Okay, awesome. So now we're going to be creating a new project, and let's just call this demo 6. And then like organization, our location. So we've created a new blank project. And then we're now going to go to compute engine and then virtual machine. So, why is it not? Yeah, compute engine. And then we're going to enable the compute engine API. Is everybody good? Yes, no? Okay, awesome. So then now we're going to, after enabling the compute engine API, we're then going to go to our virtual machines and then VM instances. So essentially, we're going to be creating a virtual machine on our computer to host the server for our app. So in this case, we have no virtual machine instances for our project, which is why this kind of like table is blank. So in this case, we can like create a new instance. Okay, so naming our virtual machine instance, this could just be demo 6-VM. And then basically like we're gonna set up our region. For just like good standard industry practice, you want the region that you set up your server to be the one closest to you. And that's just gonna be, we're in the US East. I feel like Northern Virginia is the closest, so let's go with that. And then basically machine configuration, it's going to be general purpose, and then machine type. This basically just sets up the size for your server. So since that like our app is like pretty small in terms of like its scale, we can just choose like small, because like basically different server sizes have different costs. So for example, you always should be totally fine with the Google Cloud credit. It should be enough to like keep your server running for a couple of months. But like, for example, micro would cost like $8 a month versus medium is $28 a month. So like it costs a lot more money to run bigger servers, if that makes sense. Okay, so let's just go with small for our purposes. And then we're going to essentially move on to like our boot disk section. And then we want to change this to change the operating system. So basically the boot disk is in charge of like what operating system is running on your virtual machine. And Debian is like, I don't know about you, but I don't use Debian. So let's just go with a more like common OS. Let's go with Ubuntu. Okay. Is everybody following so far? Should I go faster or slower? Yes, no, faster, slower. Okay. Okay, so we basically set up the region, we chose the machine type, we chose the boot disk like for the OS, which is Ubuntu. And then now we can, last thing to do is setting up the firewall. Basically, so firewall is like linked to like the security of your VM. And what we want to do is allow HTTP traffic for like, you might want to disable or enable this based off like the level of security for your app, because HTTP stands for Hypertext Transfer Protocol, which is not the most secure in certain situations, which is why you might want to disable this in certain cases. But for our uses and purposes, we're going to want to enable HTTP traffic. And then now we can finally, oh, hold on. But back on track, we basically just created our virtual machine. to basically host our server. Okay, so like looking back to our, okay, great. So now we have our container has been pushed to Docker Hub. Okay, so let's go back to our server. We're just currently waiting for it to load. When it like status is like a check, we'll know that it's like been loaded fully. Okay, perfect. So we created a virtual machine for our server, and then we have our internal IP address, and then we have our external IP address, and we can SSH into the server. And basically SSHing into the server is basically like logging into the server, gaining that kind of like inside access. Establishing connection. Okay, perfect. So now we've set up a, oh yeah. So now we set up, where's the, yeah. So, oh, okay. So now we set up a server for our app. So it's like this is a VM, kind of like a computer within a computer. So we ls, there's nothing in it now. And basically now what we need to do is essentially download Docker and download Docker and Docker Compose into our server for basically internal use, so it's able to use it. So if we go to the Cornell App Dev textbook, oh, right there, yeah. Okay, so back to last week's demo to Docker installation. So we want to go to Ubuntu Ubuntu installation because it's like Ubuntu server. It's a Ubuntu virtual machine. Okay, so basically what we're gonna do is follow these steps to install Docker on our server. Okay, so it's basically a lot of just copy and paste. Yeah, just copy. Yeah. Okay. Okay.
You can go to the other window, like, can I?
Where's the? Sorry, guys, this is not my computer. Okay. Okay. So we're basically going to copy and paste and follow the steps for setting up Docker on our server. Okay. So very stand. Oh, did I do it twice? Okay, whatever. Oh, okay. Okay. Very not fun stuff. Okay, going through this semi-quickly. Okay. Okay, perfect. Okay, so now we've downloaded Docker Compose, Docker, just like regular Docker on our internal server. And now what we want to do is install Docker Compose. Where is it? Okay, no. Oh, I think it's
Show the Docker deployment.
Yeah.
And then
Oh, okay, yeah, Docker Compose. So to get to this page, you just go to deployment lecture 6 and then under demo. So Docker Compose again on here. Not that fun stuff. Okay, perfect. So now we have Docker installed and we have Docker Compose installed. And now what we want to do is essentially insert our Docker Compose file into our server. So you see how in our original, oh, this is the wrong, my bad.
We can close it. Yeah, close it.
Oh, where's the, okay, yeah. In our original file, we have our Docker Compose file here, and this is on our local machine, our local server. And we basically want to duplicate this file on our server for on our virtual machine, on the virtual server, for it to have a copy there as well. So what we can just do is, well, okay, first we can create the Docker compose file on our server by basically doing vim docker-compose docker-compose.yml. And what this is doing is Vim is a text editor, the same way how you have like Atom and VS Code. Yeah, those are the main ones. Vim is like a built-in text editor in your terminal. And essentially, if you do Vim space a file name, it either edits that file if it exists, or it creates a file with that name if it doesn't exist. So what would you do is just Vim docker-compose YML to then basically create that file in your server. And then Vim, it's like the syntax, how to use Vim is kind of tricky. Basically, you press I. So now Vim is in its editing mode, and you're able to essentially insert text and copy, paste, etc., and edit this text file as you would any other text file. So what we want to do now is essentially go to our Docker compose file, copy this information into our Docker compose file in our server. And then essentially the only thing that we want to change is, instead of port 8000, we want to change it to port 8000. What this means is that the reason why before it was like 8000, it was essentially like mapping, the port within your terminal to your port to your container. So the first port represents the port in your terminal, and the second port is the port in your container. And we're changing this to 8000 in our internal server, because 80 is essentially like the default port for your terminal in general. So we just want to make that change. And then now we finish editing our Docker compose file on our server. We just press :WQ. Oh, okay. Escape, sorry. We press the escape key and then :WQ. And then we press the escape key to basically stop what we're currently doing, which is editing. And then :WQ, W is for write, and then Q is to quit. So basically what we're doing is we're saving and we're quitting. Okay, so now we've basically made our Docker compose file in our internal server. So now what we want to do is, oh, do we have time? Yeah. Now let me just finish this. Now what we want to do is essentially change the, we basically want to pull what we pushed from Docker Hub earlier. So what we're going to do is docker pull, and then the name of the image that we pushed earlier. So that's going to be Najima / demo 6. What was it called? Let me just get the name. We basically just want to pull the file we pulled earlier. So we're just going to pull this file. So docker pull this file. And then, well, since we're in a virtual machine, we have to put the word sudo in front of all our commands now. There's a way to basically, you can install something to get around doing this. And you can do that on your own if you're like really interested, or you just don't want to type sudo in front of every command. So, docker sudo. Oh.
In here-ish, but there's like this and this. These last two.
Oh shoot. Okay. Yeah.
I can stop the Docker pulling it.
Yeah.
I don't think I should have run this command. Yeah, this is a check. Yeah, sure.
Okay. Okay, just finishing Docker setup. My bad. Okay, now let's try docker pull the image that we pushed to Docker Hub earlier. Okay, we are running low on time, so we're going to stop demo for today and then move on to the Kahoot. Yes.
Okay. It is 7:30, so we'll get started. So I'm going to quickly recap what we did on Monday, for those of you who weren't here, or for those of you who might have forgotten. But recall that last week we covered containerization with Docker, right? So what we did last week was just make a container, or make an image, sorry, called demo6, and put it onto Docker Hub. So in Docker Hub we have an image called demo6, right? And we also made a virtual machine on Google Cloud, and we installed Docker and Docker Compose on that machine. And now we're about to run the app on our virtual machine that's given to us by Google, right? So one quick thing that I want to mention, was anyone trying to follow along on Monday and had this network issue that we were facing for like 4 minutes-ish? No? Okay, that's okay. I think that if you guys end up using your Cornell accounts to try to do this Google Cloud stuff, you might run into that same error that we had on Monday. So I'm just going to quickly show you how you can work around that. So before you actually create your virtual machine, and this is new, by the way, so I think Cornell messed around with some like Google Cloud stuff that might cause this, unfortunately. But what you'll need to do is click on this little sidebar, this navigation bar on the top left, go to VCP network, and then go to VCP networks. And once you're there, you should see a page like this, except you shouldn't have anything here. And what you can do from here is click on Create VCP Network. Call it whatever you want to call it. I just called it default because that's just the one I'm going to be using. You can see I've made multiple attempts on this already, but let's just call it demo6 VCP again. And the only thing you'll have to change is to change this subnet creation mode to automatic, and then tick all of these firework rules that will allow HTTP requests to be made to your server. And then that's it. And then hit create. And once you've created it, if you go back to your virtual machine creation page, you should be able to select it from your network interfaces drop-down menu. So I know that was kind of like blabber. You might have just like gone out one year, but when you are reviewing the demo, I think this will be helpful. So make sure you review this part. Otherwise, right, we have our virtual machine set up, able to SSH into it by clicking on this SSH button. So yeah, any questions from Monday, or are we good to continue? Cool. Oh, right. Also, one more thing I want to mention is, if you're on an M1 or M2 Mac, when you build your Docker images, instead of doing the Docker image command that you would usually run, and I'll make an end post on this as well, because this was something that occurred last semester as well, but you'll have to put this, platform Linux AMD 64 thing between your build keyword and like your tag flag. And this is to kind of like identify or to tell Docker what platform to build your image for, because M1 Macs have like a different, very, very different environment than like the virtual machines will be borrowing. So yeah, just make sure you write this if you're on an M1 or M2 Mac. And yeah, that's it.
Okay. Hello, everybody. Picking up from last time. To start off, we can go back to our server's we can SSH into our terminal, our online terminal here. So this is the virtual machine that we made last time. So we're SSHing into our in-person or online browser that essentially Google is hosting for us. Okay. Taking some time to load. Okay, perfect. So from last time, we can just check which images we currently have on this server. So sudo docker images. Okay, so last time we have our latest, which is that's the latest image we pulled onto this server. So now what we want to do is we can just check how the server is running, testing using Postman. So to do this, we basically have to docker compose up to get this server running. So sudo docker -compose up/d. Okay, so now our server should be running, and then going on to Postman, and we can just go back. Oh,
Sorry.
you deleted it, or
No, it's in the.
okay, going back to this was originally demo 4, so we can just like make a copy of this collection.
Right click on it.
Oh yeah, duplicate. Okay, yeah, making a copy of this collection. We can see getting all tasks using this server's I guess IP address. So this, as I mentioned on Monday, our online server that created by Google Cloud, we have an internal IP and an external IP. And the external IP is basically the address that's available to everyone. So since our server is currently running, you could input that 3.34.15, et cetera, into your like Safari browser, and it should upload a web page. Oh,
so try
yeah, so this is the base endpoint. So let's try hit the their task endpoint to get all tasks. And here we have all tasks. And then if we try test this in Postman, what we can do is just copy this address and then go to Postman, get all tasks, and instead of localhost 5000, we'll then put in the address for our online server. So that would be this here. Okay, awesome. Now when we get all tasks, we get what we expect. We have in using our server's endpoint 34.15, et cetera, we can get all tasks. Okay, yeah. So now going back to our main endpoint, we want to basically now redeploy, and then how we can make changes to our original app and then redeploy it so it's not like permanent. So going back to our VS Code with our code, we have this base URL greet user, and then it's like hello world. So maybe instead of like hello world, we could just like hello class. So we've made our changes, and then let's go back to our terminal, and then we basically have to rebuild our container and then push that to Docker Hub. So Docker build platform, et cetera, SSHing demo 6, and now we're going to be changing the version. So let's change to v1.0.1. And then after this, we want to push it to Docker Hub. Okay, awesome. Now we just want to push this to Docker Hub. So that's Docker push our Docker Hub username, which is snajima. I spelled that wrong. Najima/demo6. And then the version we want to push, demo 6. And then the version, demo-6. And then the version that we want to push, which is v1.0.1. And then if we go to our Docker Hub account, Docker Hub, these are the images. This is the repository that we currently have. And then we just pushed v1.0.1 a few seconds ago. So now when we go back to our online server, we essentially have to Docker down to basically stop our container from stop the current container that is running. So docker-compose down. Okay, so we stopped our container, and now we want to basically pull the Docker container that we just pushed. So, okay, so now sudo docker pull, and then again, our Docker username, najima/demo-6, and then the version that we want to pull, so that's v1.0.1. Oh, sudo docker login. Oh.
You spelled it wrong.
Oh. Oh, Najima, not Najimi. Najima. Okay, awesome. Now we're pulling the container that we just pushed, And now what we want to do is basically tag what we just pushed to be our latest version. So that's going to be sudo docker tag again, your Docker Hub username, snajima /demo6 v1.0.1. And then we want to basically tag this container to be associated with the tag latest. So that's going to be, again, snajima /demo-6, and then the new tag that we want to rename it to, and that's going to be latest. Okay, now that we've done this, we now want to docker compose up. And the whole point of renaming what we just pushed to be docker latest is because docker compose automatically runs the container with the tag latest. Okay, so now we're running the container that we just pushed. So if we go to our tasks, it's originally, oh, I should have, oh, okay. Originally it was supposed to have like, I should have refreshed it before showing like the task that was shown on Postman. So it should have displayed like ID1, hello, ID2, description, boo. Like I should have refreshed it before to basically show that the tasks didn't stay, but honestly, I forgot to. But the whole point of me redeploying was basically just show that if you redeploy without using a thing that I'm about to show now, there's no basically persistence, and your database is going to reset because in our dockerignore file, we included our database. So basically, the database isn't uploaded to your server, and basically every time you redeploy, that server gets reset, and there's no way, as we currently have our server now, there's no way to continue consistency. I think I'll have to fix this in post-editing. But basically, the whole point of me doing this is to show that there's no consistency unless we use something called volumes. And the whole point of volumes is that it's used for persisting data, and you're able to map a file from outsider container to a file insider container. And that allows you to have data consistency. Is everybody following? Does anybody have any questions? Okay. Oh, yes. If I close the SSH and compose and it's still up, would it still be running? Yeah. It should be, I believe.
No, yeah, it will.
Yeah. Okay. Sorry about that, guys. The whole point of me doing that was basically show how like the data disappears before if you don't use volumes, which I'm about to show now. So, okay, volumes basically used for data persistency. So to do that, what you would do is go back to your server. Oh, this is not it. Okay. We go back to our console, our folder, and we basically want to map a file from outsider container to insider container. So first, what we have to do is create the file that's outsider container, and to do that, that's going to be touch db todo.db. So what we're doing in this command, we're creating a file called to do. So if we ls, we now see the two files in this is our document compose file, which we made from Monday, and our to-do file, which we made just now. And then what we want to do now is basically set up a connection between this file outside of a container to a file living inside our container. So to do this, we now edit our docker compose file. So that's going to be vim.
Hey, everyone. So just quickly wanted to go over two things that we covered during demo that might have been a little confusing to understand due to some hiccups. So the first thing is creating variables in Postman. This URL, that's going to be the URL to hit your server's endpoints. It's a bunch of numbers, and it might be a little hard to kind of type this in every time. So one thing you can do is set a variable in Postman. And the way to do that is by clicking on this little eye icon on the top right, and then under globals, hitting the button that says add, typing a variable name. So in the demo, we called it server URL, and giving it the value of the external IP of our server. So I'm just going to copy and paste this in. Cool. And we're going to save this by hitting save right here. And that'll give this variable the value that we provided. And so now if we go back to our endpoints, instead of localhost 8000, right, we're going to be actually using our server's IP address. And the way we use the variable that we just created is by typing two curly braces, and the variable name inside of it. So I'll demonstrate this in a sec. But the other thing I wanted to cover is probably the more important one is the concept of volumes. So in our Docker compose file, there's a few lines that I guess I wanted to cover. So this line right here, volumes. What this is saying is that we want to map one file from outside of our container, i.e. within our computer, to inside of our container. And the error we were having during demo was that we didn't have this instance folder that the to-do.db file is in. And that's most likely due to either a Flask or SQLite update. I'm not really sure which, but you actually need this now. So I'm going to demonstrate what this volume thing actually does. So let me uncomment this real quick and save this file. And now if I sudo docker compose p, right, I'm going to be running my server now. So now my server is running, right? And here are some of the tasks that people added during demo. So we have 6 tasks right now, right? Some of them are, I guess, a little mean to our customers. And let's add one of them. Let's add another one of our own. Let's go to create task. And in our body, maybe one thing we want to do is, I don't know, get better at Smash, because that was one of the themes from demo. So that's the 7th task that we added. If I refresh this, I can scroll down and see that my task was successfully added. So the point of having a Docker volume is we want this data to persist. Every time we deploy a server, we don't want, or deploy a new version of our code, we don't want our data to get wiped every time. Cool. So I'll go back to my terminal on my server's computer. Sudo docker compose down. And then if I sudo docker compose back up, you can see that this, and I refresh this page, you can see that my data persists. However, right, let's go to our Docker compose file again and actually comment this out this time. Okay. So now the mapping from our the mapping of the file from inside the container to outside the container is no longer there. So if we docker compose d, meaning we take down the current server and bring another version of it up. And if I refresh this page, you can see that all my tasks are gone. So this is because every time we download the image comes with a brand new DB file, right? And that DB file isn't going to have any tasks in it or any data in it. So unless we actually map that file from inside the container to outside the container, that data is not going to persist. So that's what the demonstration of volumes was for. So hopefully that clears things. And yeah, good luck on your guys' assignment.
Moving on. The last thing I wanted to touch today was environment variables, which we mentioned last time was essentially like, you don't want to expose private information to the world, and you wouldn't want to do that. You wouldn't want to do that by like pushing it into Docker Hub, but in certain cases, you do need certain information. Like certain people need this certain information, and the way that you get around doing that is you give these qualified persons these environment variables, so they have the necessary information. So basically, to do that, we would create a .env file and say, let's for example say for whatever reason, name Shungo and net ID SN685 is like super top secret, and we don't want this being pushed to Docker Hub. And so to display this, what we would do is, for example, let's just replace our greeting. So instead of it being hello everyone, let's just say let's make this be hello Shungo. Well, we want it to be hello Shungo. So to do that, we would do os.environ.get, and then we want to get the variable the key Shungo. So what we were doing in our .env file is basically we were mapping a key, which is name, to a value Shungo, a key, which is an ID, to a value SN685. So going back to our app.py, we're basically reaching into our environment variables and then getting the value that's mapped to the key name. And then we have to import OS, it's imported. Okay, great. Okay, so then to show how this works, let's try build a container out. Oh, last thing we need to do is that we need to include this in our Docker compose file. So to do that, what we would do is in our Docker compose file, we would include our env underscore file, and that's going to map to .env. Oh, my bad. Oh, it's already there. My bad. Okay. Anyways.
Assign the servers.
Yeah. Okay. So it's already there. My bad. Okay. So basically, we're mapping our .env file, our environment file, to our env file. We're mapping to the file .env. Okay. Awesome. So now, when we build a Docker container out of this, so let's build a new container. Let's call this version 3. Okay, awesome. So we just built built a new image for to consider what we just edited. And now what we want to do is tag that to be latest. So, okay, Docker. No, I'm showing it on local first. Okay. Yeah, Docker tag Najima slash, I can't spell your name, Najima. Okay, demo -6. And then we're mapping this from v1.0.3 to latest. So Najima demo -6, and then we're gonna map this to latest, and then demo 6. Okay, I'll have to build this again, don't I?
No, you don't.
Oh, okay. All right, and then we just tagged it, and now let's Docker compose up. So Docker compose up /d. Okay, and now running this on our local, let's just get base endpoint, and then okay, awesome. Getting this on our local 8000 hello Shingo, our greeting endpoint works as desired. So now let's push this onto our Docker hub. So Docker push what we just built. So that's going to be 0.3. And then going to Docker hub, refreshing. Oh, she's not done. Oh, she should be done. Okay. Going to Docker hub, refreshing. Okay. So we just pushed version 3 to our Docker hub, and now going back to our Google server and then pulling this. So compose down, let's see if it's running. So that's going to be sudo docker ps. Okay, so the container is running. So let's sudo docker compose down. Oh, and also just to FYI to check what containers are currently running, is sudo docker compose sudo docker ps. Okay, awesome. Now let's pull what we just pushed. So that's going to be sudo docker pull snajima demo -6 /v1 v6 demo 6 colon v1.03 v1.0.3. Yeah. Okay, so we just pulled what we just pushed. Now we want to try this. Let's see if this works. So that's going to be sudo docker. Oh, tag. We need to tag it first. So that's going to be sudo docker tag, and we're going to tag what we just pushed. So s-najima /demo-6 v1.0.3, and then we're going to tag that as latest. So s-najima /demo-6 demo-6 colon v1.0. Oh, latest. Yeah, latest. Okay. So we just tagged it as latest, and now we want to docker compose up. Okay, it's running. So now when we go to tasks, we want to try hit our greeting endpoint, and it doesn't work. Does anybody have any idea why it works on our local but doesn't work on our running server, our like public server? Yes. Exactly. So the thing about environment variables, you have to define it in your local server, but you also have to define it on your public server. So to do that, what we have to do is go to our public server, and then we're going to want to create this .env file. So again, that's vim.env. And then basically copy the contents of our local env file to our server, essentially. So to do that, we go to VS Code.env file, and then copy that information, and then paste, escape, WQ. Okay, ls. Oh, ls, great. So now we have our Docker compose file, our to-do.db file. Oh, should be there. Hold on.
No, ls-a.
Yeah, okay, awesome. So now we have our Docker compose file, our to-do.db file, and our env file. The reason why we have to do ls-a is because basically that shows any hidden files, and a file that starts with a dot is like automatically hidden. So you can see like the .ssh, the .viminfo, .gnupg that wasn't there before. So essentially now we know our .env file has been created. And then the last thing that we have to do is basically update our docker-compose.yml file as well to include this .env file. So that's going to be vim docker-compose.yml. And now essentially we just want to mirror our Docker compose file on our local database, and then we essentially copy this in to include it as well. And essentially, since only like those who are provided the .env file, so our .env file is never going to be like pushed to the internet, never going to be pushed to Docker Hub. That's why we have to like make it locally, so it's not readily accessible to those who are not supposed to have access to it. Okay, so now we just want to include our .env file. Okay, I think the indentation might be, okay, yeah. And now when let's sudo docker compose up. Oh, did I think I did, yeah, let me docker compose. I don't have to. Okay, yeah. Okay, perfect. And now it works when it didn't before. So just to like recap, basically we made a .env file and then edited our Docker compose file on our local database. And then when we push that we don't push the .env file to Docker Hub. We then are working on our public database, our public server. We then need to make a .env file and edit the Docker compose file there as well. Does anybody have any questions? Does everybody follow what I just did? No? Okay, that concludes demo for today. We'll now get into the Kahoot.
I try the tasks thing, like letting people put tasks in.
Oh, yeah.
Can you do that?
Yeah, sure. I mean, okay. Well, if anybody wants to add tasks to this essentially, you can just like go to this IP address and then add what you want to add, I guess. Oh, yes.
Is the number of like things supposed to be on all that?
Pardon?
Like on the left, just like mine.
Oh, yeah, hang on. So sorry. this like the reason why mine looks like this and why yours might not is because I have a Chrome extension called JSON Viewer. I was gonna mention this too. But yeah, this allows JSON outputs to be like printed nicely on the Chrome browser. Anyway, so this is something we did last semester as well as like a little fun thing. The whole point of deployment is that everyone is able to access this endpoint, right? So if you go to Postman right now and type in this endpoint and make a post request to create a new task, your task will show up here as well, you know? So since we're ending a little, since we're ending a little early, and since it's the last lecture of like our core series, you can feel free and just like add a task and just have a bit of fun at the end to see what everyone is up to. And please make it PG. I don't feel like I have the need to say that, but yes. Okay.
I did.
Huh?
Huh?
Are you excited to re-record?
Oh
Okay.
my gosh.
Does anyone want more time to add something? Can I refresh it? Last semester we had some like Among Us Egyptian characters in our tasks. It was kind of funky. It's a me, Mario. Yo, it's a me, Tony, and I don't like Armand. Sorry to tell you this. The assignment. All right, we're gonna start some beef. Starting some beef and lecture. Okay. Eating yummy ramen. Take a nap. Wow. Okay, let me refresh this again. See if anyone else has added. No, that's cool. Okay, so hopefully that kind of portrays what deployment is, right? Everyone can access it now. It's not only on my local computer. And yeah, this is like kind of a cumbersome process to like deploy stuff. So I'm sure everyone will be referring back to this demo like I did when I took the course, but yes, we will start the Kahoot now. Any questions? No? Oh yeah.
Do you have to do anything for like the front people to access this, or like is it their job?
No, that's their job. So if you actually define the endpoints, and you can like, actually, why don't I just plug the iOS and Android courses right now? If I know there's some people in here that are either taking iOS right now along with Backend, or took iOS last semester, iOS or Android last semester, and are here now. So if you want to learn more about like how to actually take in this data and like interpret and parse it and display it on a screen, then iOS and Android are maybe courses for you to take in the following semesters. I myself am not artistically talented enough to do that, but maybe you are. So yeah. So this is how to deploy it, and now it's publicly accessible for front-end members and web browsing and anything else to see. Any other questions? No? Okay. You want to say?
No,